Hello Chem 241 students, this is Professor James Ormward, and today we're going to talk about IR spectroscopy, sample preparation, and running the instrument. Just want to make it clear from the get-go, if you need any information on data interpretation or theory of infrared spectroscopy, you need to view your textbook or the other videos. This video is specifically focusing on the lab component, where we're preparing a liquid sample, a solid sample, and running the IR for both, as well as collecting a background. All right, without much further ado, let's get started. For the first sample today, I'm going to go ahead and prepare a liquid sample of ethyl acetate using a salt plate. So if you saw the theory video, you should have saw that we use salt plates because they are invisible to IR and they hold our samples just fine. Just make sure that you don't use any water on them for your cleanup. So starting off, I always recommend that you clean these, and you can use either acetone or dichloromethane to clean them. And you just place down a paper towel and just soak them with whatever solvent you're going to clean them with. Usually if there's nasty sticky stuff on there, the dichloromethane works a little bit better than acetone, but it all depends on what you got in there. Oops. Just pour it on there, and then I kind of just wipe it off both sides with the paper towel, and then I'll wipe it dry with a chem wipe. Alright. If you get some of the dichloromethane on the counter, not a big deal. It evaporates pretty quickly just by blowing on it. Yeah, breathe the fumes in. Okay, and then you want to get them dry with the chem wipe just in case you got something on the paper towel you don't want on your sample. Alright, to prepare a liquid sample, it is extremely straightforward. All you got to do is put a few drops on there and sandwich these two plates together. Depending on how thick your sample is, you may have to put more or less, and how much you need, you're going to have to just take a look at the data to see how much you need. Oftentimes with a really volatile liquid like ethyl acetate, like we're using today, you may have to use a lot of sample. And then something thicker like Caro syrup or something, you just need like a teeny little drop, and that's enough. Alright, so what I did was I sandwiched the samples between the two sodium chloride plates, and then you set them on their edge on this little holder here, and then this will go into the instrument. Alright, here's the IR instrument that we're going to be using for our analysis here today. And whether you are running a solid or liquid sample, the way you set it up is pretty much the same. So you open up the hatch here, and then inside here, our sample holder. And then here is our sample holder I showed you guys earlier. This literally just slides in there like so. And whether you're doing solid or liquid sample, it's the same setup. So for your liquid sample, you just go ahead and set it like this, and go hold them on their edge and just place it in there like so. Close the hatch, run the instrument. For your solid sample, literally the same setup, but instead of having it on the salt plates, we have it in the nut as I showed you guys earlier. Go ahead and set it on there, drop it in there, and you are good to go. Don't forget to close the lid because ambient light will mess up your data. Alright, for this next part here, we're going to go ahead and show you how to run the instrument itself. I showed you just a moment ago how to load a sample. Alright, so the software you're using is called Easy Omnic. The first thing you want to do is collect a background. Make sure the lid is closed for collecting your background. So collect background, hit OK, and then be patient here. You should see a progress bar towards the bottom here. Typically does about 8 scans. It'll let you know when it's done. So the background is basically taking an IR scan of the air, so things like carbon dioxide, water, things from your coolant of your AC unit might show up in your measurements. There it goes. You gotta be patient. Remember to be patient. Okay, it's saying there that data collection has stopped. And before I move to the next step here, I did want to talk a little bit about what we're seeing here. So this is what a typical background looks like. This broad peak here in the bottom, that's actually due to the water in the air. These are your hydrogen bonding OH peaks. The more humid it is outside, the deeper this peak will be. This one here, oftentimes will show up in data, even if you do a background. And these two peaks here are due to the different types of stretching modes of carbon dioxide. So there's the asymmetric and symmetrical stretching, and able to see both different types of asymmetrical stretching that CO2 can do. So if you ever see this peak here that looks like a double peak in the triple bond region, that's not a triple bond, that's your carbon dioxide. Okay, we are now ready to run our sample. So after you do the background, remember to make sure that your sample chamber is empty, otherwise it'll include your sample as part of the background, and you'll get a flat line. So now our sample is in there, and then go ahead and say no to that, and then it should be collecting our background. Alright, so now that after we have the background, it's now prompting us for a sample. So go ahead and prep your sample. I recommend if your sample is highly volatile, like a liquid, you prep it right when this screen pops up, and then put it in there right away. If you take too long, it may evaporate before you get a chance to get your data. Alright, now we wait. Window yes. So we do have a little bit oversaturation on the sample, but it's okay here. But if you see this bottoming out on the peaks, that's typically an indication that you have too much sample. In the case if we were in person, if these were flat line on the bottom, I would have you guys redo the run with a little bit less sample. But this is fine for today. You then want to label your peaks. We do this by hitting the Find PKS, Find Peaks button up top. And then this line, you basically click where you want it to go. And I'm going to go ahead and click here. So basically this line here, we click, it'll identify peaks that are below that line. So you don't want it too high, you don't want to get in the noise. Just get these peaks down here. That looks good to me. You then go ahead and hit replace. There we go. We now have the IR spectrum of acetanilide. Make sure that you get a screen cap of this and identify any peaks, and make sure that you mention these in your report. This peak's not showing up very well. I would just go ahead and say approximately 1700 for this one. For some reason the Find Peak option is not labeling it, but it's okay. About 1700. It's pretty obvious. It's a carbonyl stretch, right? I hope you know that by now. Next sample, we're going to go ahead and prepare a solid sample. So the way this is done is, first, the key ingredient is anhydrous potassium sulfate, KBr. The key is that it has to be anhydrous because the water will mess up your sample if it's the hydrated version. And typically you want to use roughly 9 or 10 parts to 1 part a sample. So you don't have to measure it out exactly. So I don't want to see any of you guys measuring out 0.1 gram of this and then 0.9 grams of this. You just kind of eyeball it. The key is that you have more of KBr than you have of your sample. So I'm going to go ahead and just scoop some in here. It's not really an exact amount. It's going to grab about that and then put it in there. And then I'm going to try to grab just a teeny sized amount of the actual sample itself. So, there we go. And then it's going to go ahead and tap some in there. And then with the mortar and pestle, go ahead and pulverize it into a fine powder. Remember, when you're using a mortar and pestle, you need to actually press roughly along the walls to make sure you're getting a nice fine powder out of it. Don't just push it in the middle. Push it along the walls. All right. Oops. I gotta clean my spatula off. So the next part here is we're gonna make a pellet out of this. So the reason why we use KBr as our support here is because it turns out that if you put KBr under pressure, it turns to a glass-like substance, and then your crystal, your compound will kind of be stuck in between the glass. And what I have here is just a nut and bolt combo, and they are machined to be perfectly flat with each other when pressed against each other. So we essentially have a sample chamber in here, and the trick in doing this right is adding the correct amount. You have to use just a teeny little amount. I'm going to use probably just the tip of the spatula here. You want just enough to give a light coat of the surface inside. If you have it too thick, then when you press the pellet, it'll be opaque, and then the light won't be able to pass through it. The IR light needs to be able to pass through the sample. Right, I'm not sure you can see it very well on camera there, but just a little bit enough to coat the surface there. Yeah, it's kind of falling over when I bring it up right like that. But come on. That'll have to do. We'll see how it comes out. And then you just squeeze them together, screw them together, and then you take it to the vice grip. All right, let's get right here. See it okay? You just put it in the vice grip, don't get your fingers caught, and then you just tighten it enough where you're going to be able to undo it. Most procedures say to leave it in there for about 2 minutes, but honestly I count 10 as enough most of the time. Seconds. Alright, just take it out of here and then we'll open it up and see how it looks. It's like Christmas. Open it up, see how good it is. Alright, see how our sample came out? So see it very well on the camera. But you basically want it where if you hold it up to some light you can see through it. I got it kind of thick in the middle there, but around the edges is transparent. See on the camera there, kind of see me through it a little bit. The IR light will pass through. This will work. All right, let's switch over to the instrument and see what it looks like. Okay, we have one more sample to do. I have the solid sample that we prepared earlier, and I did the background already. So I'm going to go ahead and drop it in here and hit OK, and it should give us a scan of our solid acetanilide sample. This is always the moment of truth. You hope that it worked for your solid sample. If it didn't work, you just make it again. Be patient. Don't be too upset. Just do it again. So we do have quite a bit of sample on there. I think it's okay. But we can go ahead and identify our peaks just like last time. So find peaks. Remember, anything below this line will be labeled. So I'm going to go ahead and bring it down here. We are seeing our 2 carbonyl stretches in there. Everything looks a little bit off to me a little bit, but this is what the data says. So these are the 2 carbonyl stretches right here that we should expect to see. All right, hit replace, and then you go ahead and print it. Control P. And then we are done. The rest is going ahead and sit down and interpret your spectra. I will try to include a still image of these so you can get a better quality image to take a look at for your reports. All right, everybody, have fun doing your reports, and I'll see you next week.